Hi, warm welcome to you. We are continuing the factorization with algebraic identities. In the last video, we have seen some problems solving using algebraic identities. We are continuing that. So let's look at this problem. If a plus b plus c equal to 9 and ab plus bc plus ca equal to 26, find a square plus b square plus c square. If you see here, there is only one formula which is fitting into this, where you have x plus y plus z whole square equal to x square plus y square. This is what you have to find out, and has been given to us not 2xy 2yz plus 2zx, but if I take 2 common out, I have the remaining value. So what I will write a plus b plus c whole square equal to, according to the formula, a square plus b square plus c square plus 2 into AB, 2BC, 2CA. So I can take 2 common, say 2 into AB plus BC plus CA. Now I have been given A plus B plus C is equal to 9. So 9 square is equal to A square plus B square plus C square plus 2 into this whole part is given as 26. So I can directly write it. This is nothing but 81 is equal to a square plus b square plus c square. 226 are 52. So if you simplify this, if you take 52 that side, 81 minus 52 is 29. So the answer is a square plus b square plus c square is equal to 29. Simply we have checked which formula fits into and we have applied that formula. Now let us look at this one. 1 minus 64a cube minus 12y plus a. Looking at immediately, I know that there is cube terms, so it should be of the form x minus y whole cube. How I know that? I should have terms 1, 2, 3, 4, 1, 2, 3, 4, and there are some negative and positive, so it cannot be x plus y whole cube, and that is the only one which fits into. So what I will do, now my only problem is, I see here if I go for formula x minus y whole cube, I should have x cube minus y cube. It looks like fine because 4 cube is 64, so I can write it as 4a whole cube. But let us see how the remaining terms fit into, and I know that I can take x as 1. So this is nothing but equal to, I will write it as, the formula is x cube minus y cube. I have to get it in the form of 3xy into x minus y, so that I can say it is nothing but equal to x minus y whole cube. So let's go ahead. We'll say 1 whole cube, that is fine, minus, I know 4 cube is 64, so I can say 4a whole cube, okay, minus 3 into, let us see whether this works out this way or not, minus 3, I can take here what common, let me just go back little bit. According to this, what I can write here is, if you see here, minus 12a plus 48a square, so I can take 12 common. I will say minus 12a into 1 minus 4a. See here, this is x cube minus y cube minus x minus y. That means it should be 3xy. Let us check that again. 1 cube minus 4a whole cube minus 3 into 1 into 4a into 1 minus 4a. This is exactly fitting into the formula x cube minus y cube minus 3xy into x minus y. So I can straight away go ahead and say this is nothing but equal to 1 minus 4a whole cube. Now how we have done that? We have compared with the formula, then we have simplified given algebraic expression into checking whether it's into the formula or not. We have seen that it's fitting perfectly. Okay, let's go ahead and look at another problem. 27a cube plus 64b cube. Now looking at the problem itself, I know it involves in the form of x cube plus y cube because I have two terms, only two terms which are having cubes. That means it should be only this one, x cube plus y cube. What is the formula for that? X cube plus y cube equal to x plus y into x square minus xy plus y square. So now we have to see how I can make it as what is the value of x here. If I have x cube, that means all the terms are cubes. So I can write it as 3 into 3 into 3 into a cube. That means I can take 1 3 here and 1 a. So I can say 3a whole cube. You agree with me? Plus similarly 64 I can write it as 4 into 4 into 4. So I can write it as 4b whole cube. This is nothing but of the form x cube plus y cube. So what is my answer for that? X plus y, that is 3a plus 4b into x square, that means 3a whole square, 9a square minus xy, 3a into 4b, 12ab plus y square is 16b square. That's how I can simplify it. Let's look at the last one before we move to the next video, where we'll do some numerical problems using algebraic identities, something like what is 999 into 999, something like that. Okay, so let's look at this formula. X cube plus y cube plus z cube minus 3xyz equal to prove or verify. This is equal to half into x plus y plus z into x minus y whole square, y minus z whole square, z minus x whole square. Okay. Now looking at the problem, I see directly the relation between this and this. I see the formula here. X cube plus y cube plus z cube minus 3xyz. Perfect LHS match. So this is super. Now only the thing is RHS side I should have x plus y plus z. So I have x plus y plus z. But after that I have x square plus y square plus zx, z square minus xy minus yz zx. But here I have something. So if I am able to prove that this whole thing into half is simplifying to the second term, then I am perfectly fine. I can say that it is equal. Let's do that. What we will do now is we will take RHS and try to simplify it. So I have half into x plus y plus z. I will simplify the next term. That first one is x minus y whole square. So I will say x square minus 2xy plus y square. The next is again y minus z whole square. So I will say y square minus 2yz plus z square plus z square plus x square minus 2xz. Now if you see here, half into x plus y plus z, let us try to simplify this. X square, another x square, this is 2x square. Similarly y square, 2y square. Let us see how many z square we have. 1 and 1, 2z square. I have 2xy, 2yz, 2zx. So this is nothing but minus 2xy minus 2yz minus 2zx. And you will see that this 2 you can take common, and this whole thing will be nothing but, if you take 2 common here, what this becomes? This becomes 2 into x square plus y square plus z square minus xy minus yz minus zx. That is what it is. 2 cancels out. So this is nothing but equal to your right hand side of the equation. So this is verified. So in the next video we'll see some problems which are based on numericals, that something like 50 and half into 49 and half, 999 into 999, that sort of problems, and with that we will close polynomials and algebraic identities. Thanks for visiting. Bye for now.